Yeah, so now we will understand what is the type of machine learning. So if you'll see here, there are total main four types. Okay, the first one is supervised learning, then we have unsupervised learning, then we have semi-supervised learning, and then we have reinforcement learning. Okay, so if you'll see here, semi supervised learning, this is the most common type. Okay, I would say that. So here what we do, here we give model the label data, okay? Meaning we will tell that both input as well as correct answer, okay? The model data learns from this example. So whenever we provide any label data and the correct answer, it learns from those examples. And under supervised, if you see here, we have the classification as well as regression. So where we have to predict any category, then we will go for the classification. And when wherever there is a predicting two numbers, then we will go for the regression. Okay, I think this is clear. Now we will understand what is the unsupervised learning. So here what we do, here we give the model data without any labels. Okay, here we just provide the data without any labels. We do not have any label here. The model find the pattern on its own. Okay, so if you'll see here under this unsupervised learning, we have the clustering, association, and anomaly detection. Okay, so suppose if you want to grouping any similar data, right, at that time you will use the clustering. If you want to find some kind of relationship, then you will use the association. And if you want to find some kind of unusual data points, right, we will use the anomaly detection. Okay, now we will understand what is the semi supervised learning. So this is I would say that this is the mixture. So here we have some label data and lot of unlabeled data we have. So what it does here, model use the small label data to understand the task. Okay, and then applies that understanding of the unlabeled data. So firstly what it does, it it uses this label data, small label data we have, to understand the task, and again that applied to the understanding the unlabeled data. Okay, so here if you'll see, we have the self learning, self training, and co-training are comes under semi supervised learning. Now we will see what is the reinforcement learning. So here we have the agent. Okay, and agent learns by trial and error. Okay, so it takes action on the environment and get rewarded or penalty. So it's work with the environment. Okay, so over the over the the certain time period, it finds out some best strategy, what works out for this model. Okay, so you can think about if if I have to give some example, I'll give that game AI, self-driving car, or robotics are the common example of the reinforcement learning. Okay, now we will understand what is this supervised learning. So if you understand the word supervised, that means there is a teacher. Okay, and who is that teacher? So the label data, if you we have that is the teacher. Okay, so and here we have the two phases. So first one is the training phases and the another one is the prediction phases. So in training phase, what it does, we give the model label data, we give the model to label data. Okay, we show some kind of photo and telling that this is cat, this is dog, this is bird, and from this example it learns the pattern automatically. Okay, so after the training we get the trained model. So if you see here in the right side, we get the trained model here, and that next one is the prediction phase. So here what we do, now we give the trained model to new image. Okay, which it has never seen before. After that it uses the what it had learned to make the prediction. So whatever he has it learned from the training page, based on that it make the prediction. Okay, so it might say this looks like a cat based on the patterns I have learned that. Okay, so this is the thing. So again just remember this thing, in supervised learning we always have the label data for training. Okay, the quality of data directly affects how good your model will be. Okay, so more data you will feed, good model you will get that. Okay, so now we will understand what is the classification versus regression. Okay, so in supervised learning we have the two problems, right? We have either classification or regression. So suppose when you have like answer is category or label, if you'll say that. So when the answer is category or label, or yes or no, I mean whether it's cat or dog, spam or not spam, right? uh, this output is discrete, right? It falls into some kind of category. So for example, if I'll say that you can see here, is this email spam or not, right? That comes under classification. Again, we will say that is this patient sick or healthy? That again comes under classification. Now we will see like we will say that whether this transaction is fraud or legit. So this again, like we are just doing the category, right? So that is classification. So if you see here, these are some kind of the algorithm like we use in the classification, this KNN, SVM, decision tree, random forest. Okay, so this is classification. Now we will understand what is regression. So when there is a number, right, like continuous number, we when we have any number, it could be 3.5, 10, 10,000, 10 lakhs, anything related to number, right? We'll just go for the regression. So if I have to give some example, like I'll give that what is the price of the house. Okay, so that is again the number, right? That is comes under regression. What marks will a student get? That again a number, like we can say anything, 80%, 85.5%. So that is called regression. That again, like we will say that what is the tomorrow's temperature, right? Again, we are talking about the regression only, because we temperature we always saying like this way, like 32 degree, 34-degree, right, Celsius. So these are some example of regression, and these are the some, like we algorithm we use that. So linear regression, polynomial, lasso, or is like we use these algorithm under regression. Okay, so just for remember, like I'll give you one trick. So suppose if there is a number, we will go for the regression, and if there is any category, right, like if you have to categorize anything, that we will come under classification. Okay, so now we will see what is the unsupervised learning. Okay, so in supervised learning we have the teacher, right? But in unsupervised learning there is no teacher, meaning like there is no label data we have. We just give the model a raw data and say like find something interesting in this. Okay, so if you just look in this diagram on the left side, you can see here, right? Uh, we have random scattered data points, right? You can see here, all mix up, like there is no label. We don't know like which group they belongs to. Okay, so now what we will do, we just run the machine learning algorithm to find some kind of pattern. Okay, so here you can see that some kind of pattern here. So the algorithm automatically finds like the similar grouping of the data points together. Here you can see here, right? Red dotted are in one cluster, blue dotted are in another cluster, green dotted are in the third one, group C, right? So this algorithm like finds some hidden pattern that we could not see easily. Okay, so if I have to provide some kind of example, like we can say that like customer segmentation, like suppose if you want to group some customer based on some behavior, like if you wanted to do for the marketing, right? So if you wanted to uh, customer segmentation, you can use that. Then anomaly detection, you can in that if you want to find some kind of unusual transaction that might be fraud, right? At that time you can use that unsupervised learning. Suppose if you want to do some kind of market based analysis, like which product are bought together, right? During that time also you can use the unsupervised learning. Okay, and these are some algorithm like k-mean, dba scan, pca, a priori. So these all are unsupervised learning. Okay, now we will see what is the reinforcement learning. Okay, this is very interesting, I think, like this is a reinforcement learning. Like think of it like a training dog. Okay, so when we are training dog, the dog does something good, you give the treat, right? Like we just give the reward. And if dog does something bad, you say no, that means penalty, right? So over the time the dog learns what to do and what not to do. So same concept we assign in the reinforcement learning also. So there is a agent. So here we have the agent that will be the decision maker, like a robot or game character, and there is an environment here. So the world it operates it, right? Like anything it would be. So if the agent take the action in the environment. So every time like agent takes the action in the environment, and environments give back the new state, whether it's a reward or penalty. Okay, so what is the role of the agent here, right? So the role of the agent is to maximize the total reward over the time. That is the role of the agent here. Okay, so suppose if we have the video game and we will say, like, if you'll move right or maybe get closer to the goal, we will just give you a reward as a plus 10 point. Okay, that means for the good action. And like, if you'll go if you'll agent will move into wall, what we will do, we will just say, like, that will be penalty, like as a 5 point. That means a bad action. Okay, so over the thousand of tries, like, the agent learns the best path. Okay, so that is the reinforcement learning. If you just wanted to talk about the real world example, so you can see here, like, self-driving cars learning from navigation, right? AlphaGo beating world champion game, right? That's also very interesting example. Trading bots, like, learning to make the profit, how to make the profit. This all are fall under reinforcement learning.